polynomial sequences. And our goal for today is to be able to define them and to determine degree. Those are our main two goals, okay? We want to be able to define what a polynomial sequence is, and actually we've already covered a polynomial sequence. And then we want to determine the degree of a polynomial sequence. So those are our two goals. So the first one being, so what is a polynomial sequence? So a polynomial sequence is a sequence with a common difference between all terms at any order level. Now, this last word that I just defined, at any order level, this order level is going to be the trickiest part. But let me let you know this. We have had a first order degree polynomial sequence. We've already covered the first order, the first degree polynomial sequence, and that one is called arithmetic. So arithmetic can be called actually two types of sequences. An arithmetic sequence is called an arithmetic sequence, but it's also called a first degree polynomial. We can also refer to it as a polynomial sequence of first degree, of degree 1. All right. So for example, 5, 9, 13, 17. Okay, so this is a sequence we've seen in the past. This is plus 4, plus 4, plus 4. So we define this as having a first order or first order level common difference. As such, this is a polynomial sequence of degree 1. All right, so now, aka arithmetic. So arithmetic can be defined as, also known as arithmetic. So an arithmetic sequence, there's on the first order, on the first level of checking the common differences, there's a common difference, 4, 4, and 4. Every difference, the difference between each of the terms is 4 on the first order. I know you're like, well, what is it? What do you mean by for second order and third order? Like, what do you mean by that? I'm going to explain. But first, I want to make sure I make the connection that a first order is an arithmetic, degree 1. Questions there? Let's talk about a polynomial sequence degree equals 2. This is also known as a quadratic sequence. So this is known as a quadratic sequence or a polynomial sequence with degree 2. A quadratic sequences have a common difference on the second order level. In other words, there's the difference of differences. The difference of difference. And you'll see when I get in what I mean by when I go into that part right here. All right, so the difference of the differences is the same. So this is not arithmetic. Now I am not going to be making you find the formula. Because our class has such a wide span of math levels, not in terms of like strong and weak. I'm talking more about the courses that you're in. The method involves some rather not intense, but a really big push in a system of equations. And I don't want to go there for us. So I just want us to be able to identify these types of sequences and say, hey, yep, that is it. It is because here. This is a quadratic sequence because here. So for example, show that the following is a quadratic sequence and state the common difference. And my sequence is 1, 2, 6, 17, or 15, sorry, 31. So here is my sequence. Okay. Did I do something? No. I think I did it a little bit off, sorry. Oh yeah, I did it wrong. 1, 5, 12, 21. There it goes. Sorry about that. So 1, 2, 5, 12, 21. All right. So let's check the common differences. The common difference between 1 and 2 is 1. Between 2 and 3 is between 2 and 5. That's 3. I messed up the sequence again. Sorry about that. That's 10 and then 17. So sorry. 10, 17. Won't happen again, I promise. Plus 5 and plus 7. So if we look at the common differences, and we can spend some more time talking about, like, there's a pattern here, right? And a lot of sequences is all about patterns. But if we look at the common differences, you can kind of figure, if I asked you, hey, what is the next term? Well, you can see can anybody tell me what the next term would be in this sequence? And I'm not going to ask you this on your homework, but it's a very good thinking process. Can someone tell me what the next term is going to be and why. You can do it in the chat. You can speak out loud. I'd appreciate you speaking out loud. But what would the next term be?
Oh, it would be 25.
Close. I think you just added. Check your addition. $26. So the next term will be 26. I believe you said 25. But the next one will be 26 because why?
Because in the sequence you have to add an 8.
Well, no, it wouldn't be an 8.
Right?
The next one we would add is what?
8.
No.
9.
9. We would add 9 to the next one. And then to get to the next term, we would add 11. To get to the next one, we would add 13 and so forth. So if I look at this one, I go, well, okay, it's not arithmetic, but I'm still adding something. There's something about addition. And so if I check the next level, see, that's the first level. But if we check the second level, I have plus 2, plus 2, plus 2.
Oh, I saw what you said.
So because the second level has a common difference, this is quadratic. I could have also called this a polynomial. Degree 2. All right, so in your homework, the very first set of problems is very much like this. I'm asking you to determine or confirm that the sequences are quadratic. So I want to see you finding the differences like I just did in red, and then the ones I did in purple. So for all of those problems, you're going to find differences, and you're going to see that they're going to be something like 1, 3, 5, 7. And then you're going to find the next one. Now, I could also go by 3s. I can go by 4s. I can go by 5s. So in other words, it can go 1, 1, 4, 7, 11 in terms of how much you're adding to it. The key here is that this is the same number on the second level. Okay? So that's what a quadratic polynomial is. Now, if it's on the third level, we call this. All right, okay, sorry. Now, there are formulas, but not required in our course. And what I mean by that is for a quadratic, the formula looks something like an equals, it'll look like, some value a0, or sorry, I don't want to see a0. It'll be something like a times n squared plus b times n plus c. And we would have to find the three values a, b, and c for this problem, but we're not going to cover how to do that. I mean, if it is something that you can do, I am going to give you the option if anybody wants to expand their learning and demonstration as part of their assessment, and they want to go and solve and demonstrate how to solving. That will be so. If you are a student who feels very strong about this, there is a chance for your extension in your assessment to go about finding the formulas for quadratics and demonstrating that you can do that. That would be an option to do. Like I said, I'm going to try to give you guys as many options as possible. I'm trying to differentiate the assessments that I'm going to do as much as possible, so that everybody has the ability to demonstrate what their understanding is, to expand their understanding, and to, in the end, I know what's more important for you is get a good grade, right? But we're not going to do that formula. I want to point that out. We're not going to be covering that formula. Not required. So, in a polynomial sequence, all right, if it happens on the third level, we simply call that polynomial with degree equal to 3, all right? If it has a fourth level common difference, then we call that polynomial of degree equal to 4, and so forth. So in some of your other problems, you're going to have to, it might not be the first order, might be the second, the third, or the fourth level at which the common difference happens. So the second set of problems will be like this example. Determine the degree of the polynomial sequence. And what's most important here is that you show work. All right? If you just say, oh, degree 4, I need to see that you're actually being able to do this. Sorry, I just tried to take my Newton note. I'm just trying to put up the example problem. Where are you? Where's my example? Give me one moment. So my sequence is 28, 168, 516, 1,168, 2,220, ... So that's my sequence. All right, so I'm going to take the common differences. I'm going to look at the common differences. And this is basically what you're doing in your homework tonight. You're looking for common differences. So if I go my differences here, and you can use your calculator in finding these differences, I get 140, then 348, then 500 or 652, and then 1,052. Is this degree 1? Yes or no? Is this degree 1?
Yes.
No.
No.
This is the first level. Are all those? What is that?
Is it the second order?
Well, we know it. The question right now is it first? And the answer is no, it's not first. It might be second order. We're going to check because these numbers are not all the same. It needs to be the common difference. It needs to be the same number each time. So that's the first level. So no. So let's check the second order now. I'm going to take the common differences. I'm going to take the differences between these two. I get 208, 304, and 400. Is this degree 2?
No.
No. Do it one more time. This gives me 96. This gives me 96. Is this what? So what is that?
I said, is it third level?
Yes, it is.
Okay.
So my answer here is that this is a polynomial degree equals 3. Which means, and I'm not asking you to do this, but what that kind of means is that my sequence would look like a times n cubed plus b times n squared plus c times n plus d, and then that's what my sequence would look like. It would look like a cubic. I'm not going to ask you to find it though. You are not going to try to find this, but that's what the sequence would look like. So if we wanted to try to find an explicit formula, it would be a cubic.